Welcome to another episode of Elemental Impact, where chemistry meets everyday life. In this episode, we will explore a pivotal moment in scientific history, when fire transformed from a mystical phenomenon into a measurable entity. Our guide is Antoine-Laurent de Lavoisier, a French chemist born in 1743 during the height of the Enlightenment. In his Parisian lab, during the 1770s and 1780s, Lavoisier conducted experiments that became the foundation of modern chemistry, forever altering our understanding of matter, change, and nature's unseen forces. Weighing fire in a serene, sunlit lab at the Arsenal in Paris, Lavoisier stood near a balance, an ordinary scale that foreshadowed an extraordinary scientific transformation. Before him lay a sealed glass container filled with phosphorus. He lit it. As it burned without outside air, he meticulously recorded each detail, the mass before ignition, the mass after, and the mass of each component. The outcome was surprising: the vessel gained weight. Yet Lavoisier didn't exhibit superstition. Instead, he recognized a real phenomenon: a gas from the air had mixed with phosphorus. What others struggled to explain, he quantified with numbers. This singular experiment, and many others like it, debunked the prevailing theories of the time, establishing a groundbreaking scientific law: matter is conserved. This seemingly simple act of weighing the invisible signified not just a revolution in chemistry, but also in the philosophy of science. Lavoisier's dedication to measurement, precision, and empirical evidence ignited what we now recognize as the quantitative revolution in chemistry. He transformed how chemists comprehended change, not as a mystery, but as a quantifiable phenomenon governed by laws. The phlogiston theory and its undoing. For decades preceding Lavoisier, the leading explanation for combustion was the phlogiston theory, formulated by Georg Ernst Stahl in the early 1700s. According to this concept, when materials burned or rusted, they released a substance called phlogiston. When wood burned, it was believed to lose phlogiston. The same applied to rusted metal. Initially, the theory made sense of visible phenomena, but not the invisible ones. One significant flaw: metals actually increased in weight when they rusted or burned. How could a substance lose something and still get heavier? Some desperate defenders suggested phlogiston might possess negative weight. Lavoisier identified this inconsistency. Building on Joseph Priestley's discovery of a gas he termed dephlogisticated air, now known as oxygen, Lavoisier reconceptualized combustion. It was not about losing essence, it was about gaining oxygen. He demonstrated that materials combine with oxygen during burning or calcination, clarifying the increase in weight, and ultimately dismantling the phlogiston theory. The law of conservation of mass. Through these careful experiments, Lavoisier derived a groundbreaking conclusion. Mass is conserved in every chemical reaction. Whether a substance burns, dissolves or calcines, if contained in a closed system, the total mass before and after remains unchanged. His experiments weren't just meticulously controlled, they were quantitatively precise. Using sealed glass apparatus and accurate balances, he validated his findings beyond reasonable doubt. This represented more than a new theory. It offered a fresh perspective. While alchemists once discussed transmutation and mystical transformations, Lavoisier introduced a science rooted in ratios, measurements, and logic. Chemistry had transitioned into a discipline of matter and mathematics, devoid of mystery. A new language for a new science. Scene, overlay of archaic terms evolving into modern chemical names. However, Lavoisier did not stop at experiments. He acknowledged that for chemistry to advance, it needed a new vocabulary. In 1787, alongside Claude Louis Berthollet, Antoine-François Fourcroy, and Louis Bernard Guyton de Morveau, he advocated for a systematic chemical nomenclature. Terms like oil of vitriol, butter of antimony, and flowers of zinc were replaced. New terms such as hydrogen oxide and iron oxide entered the lexicon, based on composition and reactivity. This change was not superficial. It restructured the teaching, writing, and advancement of chemistry, creating a clear, rational system that made chemistry a universally accessible science. A martyr of revolution, A hero of science. Darkens, revolution scenes, Lavoisier's trial and execution. Yet even a brilliant mind like Lavoisier's could not evade the political upheaval of his era. As a tax official under the Ancien regime, he was caught in the turmoil of the French Revolution. In 1794, during the peak of the Reign of Terror, Lavoisier was executed by guillotine. His former colleague, the mathematician Joseph Louis Lagrange, lamented, "It took them only an instant to sever that head, and 100 years may not suffice to reproduce another like it." Though his life was tragically shortened, Lavoisier's legacy endured. The broader impact toward a scientific chemistry modern laboratories, textbooks, and students at work. Lavoisier's legacy redefined more than chemistry textbooks. He transformed the practice of chemistry. After him, balances became standard. Closed systems, gas collection techniques, and stoichiometric calculations garnered attention. Chemistry shifted from craft and curiosity to a rigorous science. His influence reached far beyond the laboratory, into physiology, energy, metabolism, and the emergence of thermodynamics. Demonstrating that animals consume oxygen and emit carbon dioxide linked chemistry with biology, helping to birth modern biochemistry. Conclusion: the weight of evidence. Lavoisier's revolution transcended chemistry, it was epistemological. It posed a profound question. How do we ascertain what we know? His response, through measurement, replication, and reason. Even the most everyday phenomena, like burning wood or rusting iron, concealed truths. But with patience, precision, and the audacity to challenge old beliefs, those truths could surface. In his grasp, the balance scale represented more than a mere tool. It symbolized a new approach to understanding the world. From the remnants of alchemy, Lavoisier illuminated the field of chemistry, measuring fire and uncovering truth. Thank you for watching Elemental Impact. Join us next time as we explore more groundbreaking individuals, concepts, and discoveries shaping our universe.